Let's look at an application of file input and output. In this application, instead of reading a file that's stored on my local computer, what I want to do is download stock prices and then plot those stock prices. And also as part of this, I'm going to produce what's called a moving average. Right, so we're going to download and plot stock prices with a moving average, and I'll explain what this means here in a moment. But first, let's look at what the process is for that. So we can see in Python, I'm using this library here, and here's the link to the file I want to get, and then these 3 lines of code do the work. So if you've seen my video on file input and output, in which we read a file that was on my local machine, I did something like this. Create a file pointer to a file. I got all the lines of the file, stored as data, then I closed the connection. And in that video, I said that the underlying process generalized to other things, like if I want to interact with a database, I establish a connection, do my data exchange, close the connection. Interacting with a web page is the same thing. Establish my connection, do my data exchange, close my connection. That's really all there is to it. So what does this file right here do while we have it open? Got my data. So you see this is actually yesterday, the 20th of August. Scroll to the top because it's 1 year's worth of data, but you only have prices for 5 days of the week. You don't have weekends, so there's actually about 250 data points here. Here's a header line that tells me what each column is. So this is the date, the opening price, the high price for the day, the low price for the day, the closing price, which is what I'm going to use, and the amount of volume for trading. And this right here is for Google, right, for this date range. So how did I know what to get for this? Well, I had to do some internet searching to figure out where I could get historical data for free. So there's this place in Poland, and they do have stuff either in Polish or English, which was nice. This website in Poland, stoop.com, allowed me to download historical data. And so I put in the date range I wanted, and then it produced this link. So notice, look down here. If I hover over this link right here, we can see what I get if I click on this. And so if I click, it's going to want to save it for me. But instead of me doing this by hand, I want my program to do it. So once again, let's highlight that and look and see what we have. And then go back and look at this. That's that link right there. So that's what I hard-coded into my program. Now, if you want to generalize this, then you'd want to maybe prompt the user for a date range or something. But notice what we have here. This right here says the year is 2019, the month is August, and the day is 20th. And then this is the year 2020, August 20th. So that's the range that we get by putting in stuff here. So I could change that if I wanted to, but I'm not going to here. All right, so let's see what I had to do. So what's the overall process? For this program, it wasn't that difficult to understand the overall process. Download data. And I never saved the data on my hard drive, although I could if I wanted to use it again later. But I download the data and just store it in memory and then use it. Then I want to extract the closing prices. Three, produce moving average of closing prices. And finally, 4, plot closing prices and moving average. Seems simple enough, and it really wasn't that hard. This is probably the most conceptually challenging part, is to do it in an automated fashion with not much hard coding. So let's look and see what the program does, and then we'll explain how I did each of the parts. So I allowed the user to enter in the window size for the moving average. That is, how many numbers to use. So let's say I use 10. If you go to a historical a financial website that shows you stock prices, then they may show you or allow you to add a moving average, and they'll typically do things like 50 days or 100 days. If we go back to some of this, so I'm going back a couple of pages here. These are these Google prices. You can see there's a big drop in March of this year because of the pandemic, and now it's came back up to basically right above where it was at. So my plot should look like this. So the blue is the plot we just saw, and then the orange is the 10-day moving average. Notice it's smoother. So what a moving average is, like in this case, it's 10 days. So starting over here with these prices, it's going to take 10 days of prices and produce an average of those. And then it moves over by 1 day and takes 10 days of prices and produce an average. Moves over 1 day, takes 10 days of prices and produce a moving average. And so what that allows us to do is to see the overall trend, because notice how the prices are shooting up and down on a daily basis. What I'm interested in, if I'm an investor, is the general trend. In general, is it going up, or in general, is it going down? And that allows me to, I hope, to better understand what's happening to make better decisions. I can change the window size. Using a larger window would give us more prices to work with, but the number of averages then will obviously be smaller. So notice it stops earlier because now I'm using 50 days. So it's a lot smoother. If I use a 1-day moving average, then that means it's not truly an average. It's really just the regular stock prices. So the orange overlays the blue here. So let's say I do 2. That's right there. So it's basically overlaying it and so forth. But like I said, websites would let you use things like 50-day moving average, 100-day moving average, whatever. This one is less useful. It would be more useful if I had more data points. But if you only have 250 data points, roughly, then 100 days of those, it's not going to show me as much. All right? So let's look at the code, and then we'll go back and forth between my design and the code. All right. So here we are at the bottom of the program. I have quite a few functions. So here is the link to the data, and I start off by getting this. I'm going to pass this string to this function, and this will return the data. And one of the things I like to do in my code is to put in a copy of what the data looks like, so when I'm looking at things later, I can better understand what I was seeing. So let's see what get web page looks like. So here's code that's similar to what we saw before. The purpose of this is to tell it to basically treat the data as 8-bit characters. And then let's actually look at a couple of things. So without looking at the final stock prices. So I can turn off certain things here. So I'm going to put in the call to exit. Exit will force the program to quit right here, so it never does this part. So we won't see the plot. I just want to see what's happening here. So let's see what the data looks like before I do some cleaning. So I'm also going to do some tokenizing here. So let's print web page right here. And we see this right here. It looks like what we had before. All right. Let's do this instead. Now I get this. So see at the end here, it has these additional hidden characters. that are part of the termination of a line. And so depending on your operating system, you can have different characters. So I want to take this, and it's basically one giant string, and I want to take it and turn it into what looks like lines. So the decoding does part of that, but then I also noticed that I had to do this to clean up some stuff when I was working with it later. I also had noticed, let's print data here. Because I always start off by looking at the data. So this is what we have. So there's some characters at the end, but when I tokenize, those would disappear. I won't have to worry about that. So it's already been tokenized to some degree. So each of these strings represents a line. But then I also notice this extra blank line here at the end. So if I use the pop method right here, it removes the last thing that's in this list, because this is a list of strings, so it's going to pop that right out. So now if I do this, we'll notice that this will go away. So there, that's gone, the extra line. This right here is an extra character I would normally need to get rid of, but actually what I'm going to end up using is this number, so I don't care about that. I don't need to worry about cleaning it up. So now I want to get the prices, which is just this column. So what do? So I'm going to go through each line of this list, or each element of the list, which is a string. I'm going to tokenize it, because this right here is considered a line of the file or of data. And what I want is the closing price, which is this thing. So this is the first element, the second element, the third element, the fourth element, the fifth element, which has index 4, since the first one has index 0. So we can see that I go through every line of the list. I skip the header line because what was in here is a header line right here. That's useful to me as a human in understanding the data, but it doesn't contain the actual price, so I want to skip it. So I start on 1 instead of 0. And then I'm going to go through tokenize, and then I'm going to take what's in at index 4, convert it to a float, since it's something like this, or actually for this one it would be this number right here. I want that to be a floating point number since it has 0.77 in it, and I append it to a list of prices. So when we get to the end, or after this function call, you can see I just have those prices, right? So now how do I do the moving average? I'm going to prompt the user for a window size, but let's look at something on paper first. So let's say that this is my moving average. So I'm going to have a window size of 3. But for now, I'm going to assume it's hard-coded. So here's my prices. So my moving average will consist of, if my window size is 3, then I need these values right here. 1 plus 2 plus 3 divided by 3. And then I'll move over. So initially it was this. This will become 2, 3, 4. 2 plus 3 plus 4 divided by 3. 3 plus 4 plus 5 divided by 3. And then 4 plus 5 plus 6 divided by 3. All right? So what are the indices of this? 0, 1, 2, 3. So I'm trying to figure out what goes in each one. And so I look and say, like, just for the first one, if I'm using these prices, this is starting at 0, so I had P0, plus P1 plus P2 divided by 3. And then for the second one, it's P1 plus P2 plus P3 divided by 3. So I'm trying to look for what pattern is here so I can automate it. I don't want to hard code. Now, if I want it to always be for 3, well, then maybe I'd say something similar to this. But even then, what does this become? Well, it's P sub I. That's the first element. Plus P sub I plus 1, right? Because 1 and 0, or 1 plus whatever this is, plus P I plus 2 divided by 3. So now I look at it and say, well, geez, I'm going to let the user change their window size. So what's the relationship here? Well, I started I, and so let's see if it even worked before we figure out the rest. If I is 0, then I get 0 plus 1 plus 2. That works for this. If I is 1, I get 1, and 1 and 1 is 2, and 1 and 2 is 3. Okay, it works for that. So it looks like it generalizes to the top part if I'm using I, but this is still hard-coded, so how do I generalize from here? Well, if this is my window, what's the relationship between this and this? Well, it turns out 2 is equal to 3 minus 1, which is equal to W minus 1. So now I'm starting to generalize more. So a particular average will be P of I. Sorry, that should be a bracket. Plus P of I plus 1. Plus P of I plus 2, if we're going that big. Plus dot dot dot. Plus P of I plus W minus 1. All that divided by 3. Or excuse me, W in this case. So does it work? What if I did 2? Well, I'd divide by 2, and I'd go I. So I want to have like 0 and 1. So does this give me this? So if I is 0, so 0 plus 2 is 2, minus 1 is 1. That would give me just 0 and 1. So this is my generalization. So how do I implement this? Well, in most languages, I would use a loop, and I can do that in Python, where I would go through for one value of I, and I would go through and produce this, and then I increment I and go through and produce these again. But in Python, we can slice. So in Python, I can do this. P of I to W will give me I plus 1, I plus 2, dot, 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 down to less than W, because it's in steps of 1. If I write it this way, divide by 3. But this, I want to have a sum. So really just do that. So here's how I think through the problem. And then ultimately, based on the language, decide what the implementation would be. Something like this has to happen in any language. Because if you say I want to add, say, 5 numbers together, then you have to say add this number to this number to this number, this number to this number. That has to happen no matter what language you're using. How you encode it is specific to the language. Python allows me to do this, but also allows this. But some other languages that don't have this form, that don't allow slicing, would probably require me to do something like that. So let's see if that's what I did in the code. So now we're at produce average. And where are we at here? Right here. So I start off with an empty list. This is going to contain each of my averages. And so I have to be careful also about making sure my loop doesn't run too long, because the window size determines how far I can go. Going back at what I said here, notice that I had 6 numbers, but I produced 4 averages when the window size was 3. If my window size was 5, then I would have 1 through 5 as part of an average, and then 2 through 6 as average. I would only have 2 averages in that case. So I have to use W to decide how far the loop should go that's being used here. So that's what I do here. Size minus window size plus 1. Here's where I produce the sum of the appropriate prices. Okay. And this is basically the way I do the add one. And then, because this has to change, right? Because I go from I to the window size and then subtract 1. But as I increases, the last number here should increase. That's what I'm doing here. And then I take that and divide it by the window size and add that to my moving average. All right? So this probably could be done in some form in a list comprehension, but this is easier for me to understand, so that's what I use. All right? And then what do we finally do? We want to plot. So I want to plot the prices as well as the moving average. Once again, to see how this works. The prices are in blue, the moving average is orange, and it stops prematurely because there's fewer numbers in most cases. Let's look and see what producing the plot looks like. Or actually plotting. Plot stocks would be the appropriate function. All right? So to plot, I need a couple of libraries. There's several third-party libraries that are available in Python for plotting. The basic Python installation does not have a way to do plotting. All right, so I need to install some library. What I'm using is probably the best known of the plotting libraries, and that's called Matplotlib. But Matplotlib itself requires NumPy, so I've already installed both of these. But also then, in order to do the plotting, I need to import this library. It will call NumPy, so I don't need to import that separately. But ultimately, I want this. If you've ever used the language called MATLAB, then you will recognize a lot of this code because conceptually it's basically the same. So how does this work? Let's look and see. So in order to plot in Matplotlib, right? So I have a bunch of pairs of points. X sub 1, Y sub 1, X sub 2, Y sub 2, and so forth. What I do is collect them into essentially a vector, which here will be a list. Right? But it's essentially a vector. And so I'll have all the x coordinates, x sub 1, x sub 2, x sub n, and y will be the y coordinates, y sub 1, y sub 2, y sub n. And then I'll say plot and give it the lists, which I'm writing here using the vector notation. Like that. That's all there is to it after you build these. So we've actually already built the the y values. Those are the prices and the moving average. These will be the indices because I'm wanting something that says, okay, starting at index 0, plot a price. And at index 1, plot another price. Index 2, plot another price. Index 3, plot another price. Like that. So the x values will be 0, 1, 2, up to n minus 1 if there's n elements. So that's what I do here. X, I say range of the length of P, and then plot X and P because those are the prices. And then I do something similar for M. I had to be careful here because I've used the same X. It won't work because the moving averages list contains less element than the number of prices. And so that's then the plot. And then I can add some other nice things. The title to the page, a legend showing you what's there, that type of thing. And once again, here's what we see. Stock prices, daily closing price, where to place it, the lower left. I had to look at it to know that. 10-day moving average, that's there. So there's what we got. So hopefully that makes more sense to you. Once again, to summarize, there's the process. Download the data. I do that first because in this case, since I don't already have data, I don't even know what I'm working with. So I really have to do that first in order to understand the rest of the process, even though at a high level I understand what I'll do. But lots of implementation details are based upon knowing what the data looks like. I downloaded and looked at it first. Then I figure out where the closing prices are at. Okay, so I know I need to extract that from the data. I want to produce a moving average based upon that. To work out the kinks in this to get the indices right, both for the loop that went through the prices as well as the range of values to use in each average of the moving average, that took some work. But I had to draw some pictures and work out the indices. And then plotting was fairly simple if you've already done plotting before, which I had. Or you can find code online that will show you how to do it, so that wasn't that hard. So that's all there was to that. You might think, where would I ever use things like this? In terms of what I actually use this type of thing for, is Amazon allows you to create what are called wish lists. And I actually have about 40 wish lists. So I'm very anal about things. So like I have a list of fiction books, and a list of science fiction books, and a list of mystery fiction books, and a list of a bunch of different types of math books. So I have calculus books, linear algebra books, statistics books, and so forth, producing this. So I have a program that goes out to Amazon, looks at each of my 40 wish lists, extracts the top 4 books from each category, does something called screen scraping, because Amazon doesn't allow me to easily download my data otherwise. So I have to actually get the HTML code for a web page, go through it, find the entries for the top 4, and then I produce a new web page that just has those. And so that's that's one of the ways I use it, actually. So that's one of my favorite programs that I've written for myself. So being able to download web data is actually a very useful task. Or actually, I just realized you couldn't see a single thing I just said, or did you? Oh yeah, you can see this. So there's a use for it. So hopefully you enjoyed the video.